Hello and welcome to my vvvv gamma graphics tutorial. In today's tutorial, we're gonna learn kind of like the basic of the particle system using Fuse. So here is sort of like result. The result might change a bit after the progress, but I just wanted to share how to play around with the emission stage and simulation stage since we've been doing a lot of compute stage stuff. I think you'll be more interested. Some people might be interested in learning like the basic of the particle system, how to really design your own particle stuff. So yeah, let's get started. So this is the basic patch that I've built for today. So I'm gonna delete some of these to build everything from scratch. Yeah, let's just do it. So I just delete these ones. Yeah, I also delete all these basic setups I've built from scratch. So today we're going to be using Stride and Fuse. So if you haven't unpacked Stride, please unpack Stride and Fuse as well. And we're going to use the scene window, root scene as always, buffer to render entity, and this is connected to structure buffer resource. Make sure you have the name for it and the particle element count. Right now it's quite a big amount, but this depends on your machine. And we'll use Sprite for today. If you want to use something else, yeah, just feel free to use it. Sprite is this one from Sprite Effect in Fuse. And then we're just going to connect all this position particle and this color particle, and also the size particle. Might change the parameter later on, but at default, let's just connect these. And then from structured buffer resource, since we're going to be using the emission stage and the simulation stage. So emission stage is does all the emission part, and then simulation stage adds some effects on it. So we're going to be using these two. So let's get this group compute stage here to be connected here, and then we'll have a compute stage system, which we always need when we're building a particle system in using Fuse. So this is a basic setup. First of all, I want to add a sphere random. So this is like a random random sphere position. So we won't use this one. I think the scale in default is like 0, so let's put it 1. And then we can't yet connect this to the sphere random. We need an what was it? Attribute. Set common attribute. So we'll be connecting this to the position. And then we'll add an output, and then between here, so emission stage has two different types. First one is a mount emitter, and the second one is probably emitter, probability emitter. So there's these two, and these two are a bit different, so I'm going to explain that later on. First of all, let's just use this probability emitter. So connect this common attribute to the on emit, and then probability emitter to emission stage. And here there's a parameter called probability. So probably, let's set it to 1 for now. And you probably don't see anything, and that's because let's set the color to 111, size to 0.01, and these parameters should all be going there. If I press F9 for this, I should be able to, yeah, see a sphere. So right now, since the size is a bit too big, you don't really see it as a particle, or if you lower it down to like 1000, you might see all these particles. I mean, let's just choose whatever amount you want. I'll just make it a bit bigger. To make it more visible, I'm gonna change the size to something else. So I'm gonna add this multiply math here. Oh, forgot the extension key and mouse. And here I'm gonna make this scalar a bit smaller. What it's doing is, so the size is set here to 0.01, and if you connect this directly, the size will be this. But so 0.01 is the value coming out from here, but I'm multiplying that with 0.2, which should be 0.005 or something. So now you can see the particles got a bit smaller. And next up, before explaining these two, I want to add simulation stage. So if you go to Fuse, particles, there is what was it? Which one was it? Attribute? No, it's the force. Yeah, there's a category called force. You might not see it. Fuse, particles, and then there's force here. And then here there's like a few different forces that we can apply. Just choose whatever you want. Let's choose noise force could be interesting, or curl force could be interesting. Let's just see how that works. So adding curl force to the input. Nothing happens. Why is that? Let's try adding a different one. So if we double click this one, go back once, and then noise force. Oh yeah, now we've got a noise applied on it. So every time the particle emits. So right now the probability is like 1, so all the particles are emitting at the same time. But if we make this like 0.01, then I assume we should be able to see, yeah, particles like emitting differently. So not all in once, but it's more like a random depending on probability. I'm not really sure with this probability thing, but if you put it back to 1, then everything will just emit in the same time. So yeah. So this is it, and also this in this set common attributes. So as you can see right now, all the particles delates like every 3 seconds. But if we make this like for like 1 second, then you can see the particle lifetime changing to 1 second. So it has less, goes less out because the lifetime just finishes in 1 second, and it gets reset, and then another. So number of available element will be reset to like 1000 and goes back, and that's how it basically works. So if you want to have like a random particles like emitting every time, then you might want this probability to set it low so that you can see like something happening. But since the maximum amount is how to say forced here, and this is strange. I think it's strange. I feel like the particles are going far further than 1 second. But maybe if I reset this with F9, yeah, the lifetime got reset, and I think 1, 2, 3. Oh, it's actually going further than that. So this lifetime is not working. Or maybe I have to add a is alive maybe here. Press F9 again. Okay, lifetime doesn't matter. No, this is interesting. Set common attribute lifetime. Anyway, let's just keep on going. I'm not really sure why this lifetime parameter is not working. So yeah, this is basically how you add some noise onto the particles. Like, so we can also change the noise force like to, so like the frequency higher a bit, and then let's see it with 1 or maybe 3 seconds. Yeah. And now we have more noise. We can also add multiple simulation stage. So this one is a group of GPU void. And then here we can add noise force. In the same time, we add a node called drag. Oh no, let's add a different one. I'll just copy and paste this noise force, and then go back and I'll add, for example, a target force. Then we can set a target. So in default, target is at the center, I guess. But if we make it to the left, and then we can change it. We can also change to the right, or we should be able to add some random values here. So it's a vector 3. So if we add a shader node vector 3, we should be able to get, like, for example, let's get this, and then position, and then particle position to the noise input, and we should be able to add like different targets. So now the target for all the particles are different. So let's make the center. So now it's going randomly to this direction, for example. Yeah, so we can add these a lot, so we can still keep the strength strong, and in combination with these two, we're getting like different kind of movement. On here, we can also add some, let's say we want the size to be small when it gets based on lifetime, then we can add another multiply node here, and then lifetime, age over lifetime node. And with combining, connecting this, the particles should be deleted when it's fur, but it's a bit hard to see, so I'm gonna disable this simulation stage. Or I'll just disconnect this one and see. Oh no, let's just disconnect this target force, then make this to 1, So the further it gets, it should be small. This is hard to see. Yeah, it might be wrong. The age over lifetime. Should I one minus here? Oh yeah, this is correct. So based on the lifetime, so it's opposite. So it's age over lifetime. So I had the 1 minus here to make it opposite. And then now, as you can see, the particles get smaller when it's based on lifetime. So yeah, this is right. Yeah, this is more visible. And we can also change the color, for example. So right now in default, I've set it to 1, 1, 1, 1, but I can also control the colors here, or I can control the colors here. I basically like to control the parameters here. So I just add, for example, age over lifetime, another one, and then I'll add a node called oclab RGB, and then I just do this and then multiply these RGBA values. So 111 with this oclab output, and then we connect this one here. So based on the age, the color will change. And right now the probability is 1, so everything seems to be the same. But if we set this to 0.01, then as you can see, all these particles are mixed with different colors. And we can also change this oclab chroma thing here. So yeah, this is a default way, like the very basic way to control. So adding all these different parameters on it, you get lots of controls. You can also add, for example, if we go to this force, there's also surface force field, for example. This one can be used if you want to, oh wait, no. Was it surface force field? Oh yeah, for example, if we add a conform to SDF, for example, then we can add, like, for example, box SDF. We haven't done the SDF function actually on these tutorials, but anyway, we can add a delegate 1 1. We always need these to connect this here, and then yeah, as you can see now, all the particles tries to go like conform to this SDF that we providing here. And let's add a ray marching node to see what kind of shape we've got out of this box SDF. So we'll connect this one here, and then to the root scene. So this is the shape that we've got. This is the box. If we make it bigger or smaller, as you can see, the particles are following these. So we can turn off this noise force. Like, we can also change the track strengths and all these parameters to make things attract faster or slower. Yeah, so there's a lot of forces that you can add here. But yeah, we're not going deep with this today, so I'll just delete these two and this one as well, and just keep the noise force here. Okay, so the next step is about this amount emitter. So I'm gonna delete this one, connect set common attribute to the amount emitter, and then we'll get this one back here. So what it does is amount emitter has this amount input so that you can specify how many particles you want every frame. And right now it's not working correctly, so I'm gonna press F9 again. Yep. So as you can see right now, all the particles are emitting. So I get only 1000 particles emitted every frame. This is a bit hard to see. If we connect, for example, this, so the element count all the way to the amount emitter, what it happens is that every particle that we've selected here to be emitted is connected, is emitting in the same time in the first frame, which means that it emits 1 for 3 seconds, and then it gets resetted, and then it's emitting it again. So if you want, for example, sometimes this is very useful when you have like you know, like you have certain amount of particles that you want to emit every frame, then you can have that kind of control here. One thing I usually do is I add this called node main loop, and this actually shows us the FPS for, oh no, this not this one, it should be this one. If we make it slower, maybe we should be able to see. Yeah, but this let's just try to slow it down so that we can see F3. Yeah, this is too light for my machine to get lower. Oh yeah, now I got 60. Oh, I need a perf meter. Is it? So yeah, so right now my frame rate should be decreasing to 10, but I'm not seeing that. Oh, I'm not really sure how to get the frame rate out of target profile output, but perf meter says it has an output. No, anyway, let's just forget about this. So what I usually do is, so let's say the frame rate of this soft system is 60 frame, and I'll add a multiply. Oh no. And then the particle's lifetime is 3, right? So if I add like a multiply, and then I'll say float 32, and then lifetime is 3, and then I want every particles to be, let's say this here and this here, and I'll connect this one here. So what I'm trying to do is I'm trying to calculate like, okay, 60 frames per second, and there's 3-second lifetime, and then amount of particles I want every frame to be emitted is 1000. So this is the amount of the total amount I want. Then I just connect this one to here, but since it's integer 32, I just convert this float value to int, and then I connect this one here. So now what I'm seeing is that so all the particles will 1000 particles will emit every frame for 3 seconds. Then as you can see, so a number of available elements is always 1000, and that's because like every frame you have like 1000 left that you can keep emitting. So if I reset this with F9, as you can see, it keeps lowering down 1000, 1000, 1000, and then goes back. So this is very, if you want to have like a specific control of the amount of particles to emit, then this is one thing you can do to calculate that kind of stuff. And yeah, I think this is a basic setup for the particle system. What else should I explain? So this is the way to change the color. We can also play with distance, for example. We've used distance node several times. So we can say we have vector 3, and we want the particles colors to be different based on the position. So from the center, let's say the particle color will change. So as further it is, as closer it is, it's, I don't know what color, but as the further it is, it gets different color. I'll just change this one to lightness rather than the color. Yeah, so I think as further it is, the lightness will be low. But this one has to be mapped between -5. Yeah, anyway, I'll just get it back. Yeah. So we can also change the particle color based on the distance from each position. So we can change this one as well. We can also repeat the y-axis based. Yeah, we can make it the colors repeat based on y-axis, like the ones that we've done in the previous tutorial. So that's also possible. And yeah, that's like the basic way we can play around with. One last thing I wanted to share is a way to use the noise vector, the noise, this one, so the noise vector one, instead of using this noise force, because this one is categorized into force category, but in this tutorial we've been learning how to use these noise node. And it would be really nice if we can use this one as a source to control the shape of the particle. To do so, there is a node called integrate, I guess. Yeah. And here we can connect this one. So we can't directly connect this one here because it has to be GPU void. And this one is a vector 3. So instead of that, we can use this node called integrator. And then we add a node called delegate. And then convert this to a delegate. And then we'll add a position particle node, and then we'll get the particle position for this noise. And then we'll also add this position to the integrate, and then step size it integration mode. Yeah, this is okay. Like, I'm not sure what's the difference between, but there should be a difference. And here we just basically need to add times step size, and then let's see how that goes. Oh, and then we need to set this as a position for the position, and then we can add this to the group. No, nothing happens. There should be a node. Oh, wait. Oh, yeah. I don't know if this is a bug, but always when I don't change this parameter, it just doesn't do anything. And once I change this time, it applies the change. I don't know what this is. But anyway, so by using this integrate node, instead of having this noise force, we can actually add this noise parameter that we've been using to distort the sphere or the mesh that we've learned in the previous tutorial. And with this, I feel like we've got more controls, so we know this shape and we know what we want to do, so we can keep adding different stuff here. We can also, for example, yeah, there should be a lot that we can play around. I haven't really played around with this much, but there should be a lot of potential on these. Like we can make something like this with different frequencies. And this is pretty cool. 10 and then 0 for some values. Yeah, this is better. Let's add a bit. Yep. Then let's add an integer for the particle. Integrator for the time. And then let's keep this moving. Yeah, oh, this is pretty nice. I like this graphic. Yeah, and then we can also change the amount of particle amount to like more, so that we get more particles moving in between. Can also add this noise force here to let it like also vanish, have this noise a bit that's going out. Oh, we can play a lot with these. This is pretty nice. Yeah, lightness to 0.5. Oh, we've got really nice color. I'm gonna also add some noise here. Let's do this with position, particle, and then here I'll add a multiply node to change the scalar, to change the color here. So multiply noise color here, so that's not based on position, but now we've got it based on the. Oh wait, no, this is not what I want to do. I'll go back to the math one. I'll connect this one back to the OCLab. And then I'll connect this noise to the OCLab. Yep. Now we'll change the frequency to get the color with less. Yeah. Or maybe I'll change this one to this one, and then I'll change. Yeah, let's just figure out what color you like. I mean, I really enjoy using this OCLab to RGB. If you've seen some of the posts that I've been posting on Instagram, most of the colors I use there is basically with this setup. So yeah, it gives you really nice gradient color. Ooh yeah. Yeah, I think this is pretty much it for what I wanted to share for today. Yeah, it was a bit a mess, but I think you understood how simulation stage, like emission stage and simulation stage worked. So if you've already played with my previous tutorial explaining about PLY, you should also be able to convert the compute stage to emission stage and then add some simulation stage there, so to animate your particles as well. So yeah, that was it for today. Thanks for watching, and I'll see you next time.